Hello, and welcome to the third tutorial on using the live coding environment FoxDot. This time we'll be focusing on how to use the master tempo clock to schedule and repeat certain events. The master clock, which is just called clock with a capital C, is basically a type of queue where events are ordered based on when they should happen, with the things happening soonest near the front and the things happening later at the back. This is the class that schedules all the musical players and starts them running at the start of the next bar. So if I was to do P1, arrow, arrow, pluck, and play first 8 notes of a scale, half beat per note, scheduling of when these notes happen is handled by clock. If I print the clock, you see you get a beat value and what's going to be happening at that beat value. So there we see the pluck player object is going to be happening. Player objects like P1 have a few methods. So methods are like functions that are specific to a class. And they have the player objects have a few methods that change the player's state. For example, the reverse method. So if I call that while P1 is playing, it will reverse the order in which the notes are played. So while P1 is playing, it will immediately begin playing in reverse. I can also use the stutter method to have P1 play an extra note. So it sounds a bit weird there because when it's called, it's not being called exactly on a beat. So it tries to schedule it to happen over the course of between then and the next start of the next beat. So it feels a bit squished. If I want to call these methods repeatedly, I can use the every method. So if I want to reverse the order of notes every 4 beats, I say b.every 4, comma, and then the name of the method as a string. I'll explain that in a second. And I can do the same with stutter. So every 4, stutter it 2 times. So it'll play one extra note. So the first 2 arguments of the every method, the first one is how often, so the number of beats between each method call. Then the second argument is the name as a string. And then after that, it's the arguments you would give to the method itself. So stutter, I would say stutter 4, play 4 notes. And I can also, in the stutter method, supply keyword arguments like the octave or the panning of those notes in order like I would do with a normal player. So the reason for typing the method in quotation marks is that every method, the every method checks if the name is valid for that player. So just in case the method doesn't exist. So it does this using the Python getAttra function. So if I did getAttra p at the attribute foo, I would get an error saying it has no attribute foo. But if I do it with stutter, it tells you there's a bound method, player.stutter. So if I want to stop calling these, I just use the stop calling method. see it's stopped reversing once I called the stop calling method. So the clock itself can schedule any callable object using its schedule method. Clock.schedule, which means it can call functions and any objects or object methods and any objects that have a underscore call underscore method, such as the player objects. But this isn't always as intuitive as it sounds. So I'm just going to delete this. So let's say I want to call a function that adds two numbers together and prints that to the screen. So if I call add, it prints out 25 to the console there. If I wanted to do that every 4 beats, for example, if I want to do that at the next bar, we'll start with just scheduling one event. I did clock.schedule 10:15. What happens is that it prints 25, which is our expected output, but then we get an error saying it couldn't schedule a none type. Now the reason for that is because when I run that line, it immediately evaluates add 10:15, prints it, and returns nothing. So it's not going. So the thing it's returning is what's going to be scheduled, which is none type. So it doesn't actually schedule anything. There are 2 ways of getting around this. I can schedule add as a function and give it the arguments using args. And you can see there's a slight delay there in the bottom because it's scheduled that to happen at the next bar. Or if I want to, I can wrap that in a lambda function. So a lambda function is basically a one-line function, which, so essentially, these 2 functions are sort of equivalent. It's defining a function that only does one thing. It doesn't have to have a name, like you don't have to call it add or anything. I can just schedule it as a function. So I could do lambda add 15. And I can see it called this lambda function, which then called add 10 and 15 and printed it to the screen. It's just whatever is more comfortable for you. I prefer using the lambda method. It just sort of looks a bit cleaner than separating out the arguments, but things can be a little bit tricky if you're scheduling things in a loop. But we might come on to that in a future tutorial. So, I'll also post a link in the description about lambda functions that might help clear things up a bit. So if you want to see how this might be useful in a musical sense, what we'll do is we'll have 2 players running, and I'll schedule one to solo using the solo method. At the next bar. So if I get these 2 guys playing together, so what I did there was I used clock.schedule and scheduled a lambda function which wrapped the p-solo method, and then so that it would do a p1.solo rather. So it soloed the pluck player. It stopped any other player from playing while it was in solo mode. So I can do the exact same thing, by scheduling the P1 solo method itself and then supplying args. So run this again. So the first time I had to do it without any arguments because calling it by itself is how you activate it. So that's a case where the Lambda sort of felt a bit more intuitive. I just call it as it is rather than having to supply or not supply arguments. There's also a clock.every method. So we've got our we've still got our add function which prints two numbers. If I want to call that every 4 beats, like I did with the player.every, I can use clock.every for so every 4 beats it's printing 5 plus 10. Now changing what happens here is a bit difficult. So the only way of stopping this if I stop the clock completely, because I'm not naming the function. Like with the player.every method, we use the method name. We can use that to stop it. That's what we say, stop calling, reverse. So the only way to stop it from doing that is using clock.clear or using the control period shortcut key to do so. If you want to have a bit more control over this, we can use something called Temporal Recursion, which is used in a lot of live coding languages and paradigms, such as Andrew Sorensen's language, Impromptu, among others. So what that is where you define a function which then calls itself in the future. And they could be used to be some cool things. So again, we'll use a trivial example. Okay, so we'll use this add function again. So it prints A plus B. And then I'm going to double A and divide B by 2. And then within that function, I use clock.schedule. So if I want to, well, I'll schedule add, and if I want to not have it run every bar, I'll use, I can specify what beat for this to happen at, so which is the beat right now plus 2, so that's 2 beats in the future. Supply the arguments, which are the new A and B. That's our add function. So then I just call it. So let's say I call it with 10 and 10. It'll print out 20 times A by 2, divide B by 2, and repeatedly call it. And you can see there it's calling every 2 beats, multiplying A by 2. And if I want to stop that and comment out that line, it'll call it once, and it'll stop calling it. Or I could change what it did. So start that again. So it's printing this number. And now I want it to say, hello world. See? And we can manipulate that function while it's still calling itself. And you could use that hypothetically to send messages to SuperCollider or another audio engine if you want to make music that way, if you don't want to be bound by the FoxDot player paradigm. But the whole point of FoxDot is that it makes this sort of thing a bit easier rather than having to define temporally recursive functions. But this could be used for things like visuals, if you want to do that with Python and then call it every 30 times a second to update an image, for example. Well, anyway, that's it. Thank you for watching, and see you next time.